I met SilverThread a while back, and what I really liked about the solution is the fact that they're they're not revamping, and correct me if I'm wrong, Dan, but they're not revamping software. They're just modernizing it, and they can do it on very, very large scales, which to me was phenomenal. I saw a lot of applications because the federal government uses a lot of legacy systems. I know there's a lot of legacy in the healthcare industry and manufacturing industry, uh, academics. So I really wanted to have them on here and talk about what they do and what they can do. And please ask questions, uh, offer opinions. The whole point of this is to identify applications for these technologies, for these solutions that will work for you, work for your peers, and also help these organizations advance their visions. But with that, I will turn it over to Dan from SilverThread.
Yeah, thank you so much. I really appreciate it. Can you hear me?
I can.
Wonderful. All right. Yeah, like you said, right now we're going to be speaking about software and software complexity and the challenges associated with the fact that the heart and mind of a lot of the complex systems out there today, actually all of them today, are made up of software. This asset that we don't understand very well, that often has some major challenges, and we need to know how to cope with that complexity, how to understand it, how to gain visibility and control, and how to bring it into the future by modernizing it, both in times of great challenge, but also continuously so it can evolve in a healthy way. And that's something we as humans haven't really figured out how to do very well. And that's some of the topics we're going to talk about today. And we're going to talk about SilverThread's approach to doing that. Now, the majority of large software projects are challenged. Studies have shown that only 7% approximately are successful. If you define success as delivering on time, delivering within budget, and delivering the capabilities they originally set out to deliver. 93% are challenged, and around 40% of them fail entirely. Right, the project is killed before anything is shipped. And typically, when people talk about why this occurs, the first go-to move is to blame people. You're going to blame the developers as not knowing what they're doing or terrible leadership. It's the reflexive go-to if you want to blame people. The next thing you're going to do is you're going to blame the process. It must be that we're using bad processes in our organization while we are developing or sustaining a system. But what we're going to be talking about today is that often it's neither of those things. It's actually the health of the software itself that drives your economic outcomes and your project-related outcomes. Now, software is, like I said, the most complex thing that humans have ever set out to create. What I have in this picture is a picture of Margaret Hamilton. She has been credited with inventing the term software engineering, and she is standing next to a printout of all of the code that went into the Apollo 11 lander. And what you see on the left is the actual physical structure of the Apollo 11 lander. One question you might have is, why is it harder to do software than it is to do electromechanical systems? And there are a few different reasons, but one of them that's of great importance is the fact that the lander that you see on the left here can be seen, it can be touched, it can be understood in a qualitative way. 60% of the human brain is dedicated to understanding a qualitative sense of physics and three-dimensional geometry. So all of the people involved in developing that system, if there was rust on it, or if one of the legs was bolted to the top instead of the bottom, everyone would know. Not just the mechanical engineers, the CFO would know, the admins would know, everyone would know that you had to fix those issues. But in software, there's structure too. It's just not three-dimensional, so it's poorly understood. We don't have qualitative, intuitive, naturally evolved ways of understanding the health of those systems. And so when software gets the equivalent of rust or architecture problems, we don't do anything about it. So they degrade over time, and it's very hard to communicate about it. It's very hard to take action. Now, the problem is bigger than it was earlier. If you have a system that has 100 million lines of code, If you printed out that stack of paper, it would go 1.5 miles into the air. And no human being can understand all of that complexity. If you think about a very large software development organization, maybe 1,000 people developing code all at the same time, each individual person might be, I guess, generally understood to understand and be able to manage well 3 feet of that stack of paper. Maybe they're experts in the algorithms that are contained in that paper. And all of the people that you have working in that code base today might only cognitively cover a small fraction of what you have before you. So we're building on top of legacy. Much of that legacy is poorly understood. And yet changes to code that developers do understand can have an impact, an emergent effect on other parts that no one in the organization understands. So if you poke it over here, it breaks over there, and people have difficulty understanding why. Now here's an example of the types of problems that we have to face as a society. All right, this is a video game company that we at SilverThread worked with. And if you're a video game company, you create a video game engine. And inside that engine, you might have a physics subsystem, a rendering subsystem, Xbox drivers and PlayStation drivers. That company might also have different teams developing individual games. Right? So in this game, it happened to be a first-person shooter. It had a bad guy subsystem, vehicle subsystem, weapon subsystem. And if we plotted out the architecture of this system, we would expect to see dependencies where the games depended on the platform, and it looked clean like this. However, the first time we did an evaluation using our tools, we found hundreds of places where something in the engine actually depended on something inside the game. So we're tying this architecture up in knots in ways that cause problems. Now, here's the problem that creates. What happened was that when I asked the architects why that occurred, what they told us was that someone in game one had invented a useful algorithm. The people in the engine team recognized that it was a useful algorithm and decided that they were going to call it directly instead of factoring it out, pulling it down into the engine, hardening it, documenting it, and broadcast the availability of those capabilities to all of the teams using that platform. Instead, by calling it directly, they saved themselves a month of time because they didn't have to do all of that. That caused a lot of problems down the road, however, which they didn't anticipate. Years later, around the May timeframe, someone in game one changed that algorithm in a way that was useful to game one. Unfortunately, that patch, that software patch, got merged with other software patches, hundreds of them, got merged with hundreds of other software patches from the video game engine, and all of that landed on the doorstep of Game Team 2. Now it's around June. They spend a month trying to debug the issue. After that, they spin up a cross-organizational team between the engine and Game 2, and they spend months trying to figure out what's going on, where it becomes increasingly heated. They're blaming each other for these kinds of problems until finally they realize it's because of this extraneous link that no one remembered from years before. Now it's October or November, and for the purposes of shipping Game 2 for Christmas, they had to backport to an old version of Game 1, backport to an old version of the engine, and pray on Christmas morning that all of this wouldn't collapse. This is the problem that SilverThread is trying to help people understand and cope with. This happens in every industry where you have to integrate large systems. In the DoD, maybe one of these boxes is Northrop, one is Raytheon, and one is Lockheed. It's a pervasive issue, and it's a very deep and hard issue. So to cope with complexity in your system, you want it to be modular. You want it to look like Lego bricks that can be stuck together in ways where you have interfaces that connect them. You want to maybe think about it as a Mr. Potato Head, where you have a platform and then you have plugins that you can use that use common APIs so that you can mix and match components. You might want to think about the metaphor of having your code base broken into lollipops or Tootsie Rolls, where they have hard candy shells as APIs and then the GUI internals are protected from connection with other lollipops. So if we go away from the metaphors and look more at the science of this, when you think about what a software application should look like, if you're analyzing its health, it should be thought of as a collection of modules with APIs around them, each module being small enough that a human being can understand the complexity inside it. It should be structured as a hierarchy with a clear top, middle, and bottom. The top should be your APIs and your user interfaces. In the middle, you might have business logic or middleware. The bottom, you might have shared common utilities. And if it's structured in this way, you're in good shape. Unfortunately, your software often looks like this. People talk about spaghetti code. They talk about tangled fishing line. Picture on the left is actually a graphic called a DSM. It's a way of visualizing modularity and architecture degradation hotspots within a code base. And the reality is that code bases often, when we scan them, look more like this. In fact, 80% of them do. The good news is these things can be fixed, and we have had success helping people fix these things via visualizing them, having reports, and driving health into those systems. Now, here's an example of some of the studies we've done. We've measured the difference between the economics of an unhealthy architecture versus a healthy architecture. And in this study that I did, we found that developers in the unhealthy parts of code were only producing 8 features a year and spending 70% of their time fixing bugs. Whereas in the healthy part of the code base, those same developers were producing 20 features a year and only spending 1 day a week fixing bugs. This obviously impacts lots of things like your agility, schedule slippage, portability, cybersecurity, quality, labor costs. Here's another study I did. We found that developers working in the healthiest parts of a code base versus the unhealthiest parts of a code base, there was a 10x difference in the rate at which those developers were quitting or were fired. And so it's not just about the economics of development, it's also about the very real human experiences that developers have when they're working in code bases, right? You have the steepest learning curves in the architecturally degraded parts, but you also have the highest turnover, leading to dead zones in your software that no one understands. Here's some other studies that we've done. I'm not going to belabor them, but we've done a lot of studies connecting safety and security to architectural health as well. So here's an example of a product that we've got. We call it CodeMRI Discovery. We have the ability to put servers into an organization to analyze the health of all of their code bases. So they might connect it to hundreds of code bases and benchmark design quality and business outcome attributes so that as executives, you can see across your entire portfolio and have a better sense of what is going on so you can make strategic decisions. Here's an example of just a few of the outputs. These are benchmarks of modularity and also benchmarks around the agility of an organization and the bug labor percent spent fixing bugs versus doing feature work inside that organization. We've done a lot of work with the United States Department of Defense. So here's a screenshot of an actual portfolio that we analyzed. And this information was used in a variety of ways, looking across the systems holistically and also looking inside each one. But they used it to make decisions about whether to refactor something or rebuild it, whether to do a post-mortem on a system that had failed to understand what had gone on. Right? There are a variety of uses. Drilling in on a specific one of those systems, I can tell you there's one story where we analyzed the health of a code base, found that from a design perspective or an architecture perspective, it was one of the most challenged systems that we had ever seen, even though the code quality scores said that it was in great shape. We then did some economic predictions and showed that inside that code base, we were predicting that a new feature would take 83 days, with 50 of those days dedicated to bug fixing, whereas in an optimal system with no friction, because there were no technical health challenges, that same feature would only take 12 days. Our models projected that for every $1 million spent on future development of that system, 860,000 of those dollars would be wasted. And so this kind of analysis helped people make a multi-billion-dollar strategic decision about what to do with the future of this system. Now, we also have capabilities around helping people improve code bases. It's one thing to navel gaze and say, okay, we have problems, the baby is ugly, we have challenges, let's analyze both the health and the economics of development so that we can make strategic calls like killing a project or moving resources around. But the real thing that we want to do is drive health into these systems. So we have a product called CodeMRI Modernize. We have a patented methodology that we've come up with and used to help people modernize and modularize a code base, as well as the infrastructure surrounding it, so the build system and whatnot. But this is useful for people who have large legacy systems that no one understands anymore. They might have been built 30 years ago. You might have hundreds of people working on them. They might be incredibly important and useful, but people might be pulling their hair out trying to understand what to do with them. And it's hard to plot a path to having something that is modern and cloud native. Your choices in this kind of situation today might be either cut the cord and do a total rewrite of the system versus just live with what you have. And we're trying to help people come up with a roadmap as well as a technology to guide them in the process of incrementally breaking it apart. We do this by providing a roadmap that is based on the science of how you should go about doing this, technology that can audit the architecture not only statically, but also dynamically by injecting itself underneath the build and test process and extracting architectural features that way. And we're also leveraging our 20 years of MIT and Harvard Business School research into modularity and how to decompose complex systems. Now, here's what a system should look like.
This is Eugene.
Yeah. Hey,
so
Eugene.
I just want to interrupt you. That's a lot of information.
Yeah.
I just wanted to interject here and just pause for a minute to see if there are any questions at this point.
Yeah, absolutely.
From people, because yeah, it's a whole lot of information that you put out. So if anybody has anything, any questions, thoughts, floor's open. All right, thank you. Yeah, if you wouldn't mind, just
yeah. Well, Eugene, do you have
every few slides? Oh, go ahead.
Okay, sure. So, so yeah, we've been doing a lot of work recently about modernizing, modernizing these systems, and I was going to get into, how do we go about doing this? Ideally, if you take all of the code in a large application, you want to put it into different buckets, which you might call subsystems or modules or components, and then define the relationships between them. Right? So you want to say that module A depends on B or is supposed to depend on B. And then you want to define APIs, which is the entry point for each one, to hide the complexity inside each of those systems. And here's a picture of a blueprint that we've created of one of those code bases. And what you can see in this picture is that there are a lot of black arrows indicating that there are dependencies in the code and in the infrastructure, and that those correspond with things that your software architects would expect, because that's the way they created it to be. However, we also, if we look closely at this picture, can find red arrows that show places where the code is doing things that it shouldn't be doing. Right? Often, if you've got 1,000 software developers, you might have some senior architects, you might have some interns. And if you don't have these kinds of visuals and controls in place, every time you have, that intern is working in the code base, they might be doing something that violates the architecture or the intent of the senior leaders in the organization. And so we want to be able to catch that instantaneously every time they're doing their job. And so the other picture I have here is a command line interface that we can connect to that would allow the management system for the source code to catch those issues and report them so that you can drive them in the right direction in real time, instead of letting them fester like we saw in the video game example. Now, one of the things that we have, the goal is to drive modularity into a code base, to create these buckets, to define these dependencies, to define the APIs. And so we have a tool that can sit underneath the build and test process of an application to extract this kind of information. We can also extract it statically by using a compiler on the code. And using that information, there's a systematic approach that you can use to incrementally, first define these buckets, then shore up the dependencies, modify the build process, modify the version control system, get your installers right, get your deployment right, so that you can drive the system into a healthy state over time as a background activity. Now, what's the benefit of doing this, right? If you have a modernized code base, it can become a cloud native code base. If you have a big legacy system that was built for client server 25 years ago, it might only be designed to run on one computer. It might have a lot of useful algorithms inside it. It might have a lot of useful functionality. But if your goal is to split it up so it can run on thousands of computers around the world, then you're going to have to break it down into its constituent parts before you can do that. And so this approach allows us to get there by driving in a particular direction. In fact, in the roadmap, there's a particular place in this picture where once a piece of code gets to this point in the Gantt chart, it is ready for use in the cloud. Another benefit is that if you have your system structured in this way, it can be used as a means of customizing. So often you'll have a large product that has different customizations for different end user communities. And so by including or excluding different modular components or data sets in your installers for those different communities, you can both customize but also manage your architecture in a healthy way. And a third benefit of breaking your code base down in this way is that today a lot of people are very interested in doing distributed development across, geographically distributed teams. And one thing to understand is that that's only possible if you have an architecture of your code to match the architecture of the organization you want, because those two things mirror each other. If you want to do distributed development, you also have to have a code base that has that is loosely coupled so that you can move those parts around to reside and be developed where the different teams are. So here's an example of modularization within a company that we're working with. The company with 2,000 developers, 25-year-old code in C, C++, and prior to modularization, they were hitting scaling limits. Now that back then they were a $750 million company, and now they are a $2 billion company with twice as many developers. They overcame those scaling limits by ripping their code apart in this way. And every time a team broke out of that monolith or that spaghetti code, on average, they became 3 times as productive as they were previously. Now, here's an example of the first report that I produced for this company. I measured the code and found that there were 420,000 violations of the rules of modularity, as I call them. And just some examples.
Hey, Felix.
Is there a question?
Hey, so all right, I'm a little confused. So did you originally schedule 2 days for the demo? For the training, the whatever this thing is at Lab Central?
Are you talking to Eugene?
Okay, all right. Yeah, I don't think we.
Anthony, I need you to mute. Go ahead, Dan. I'll mute him from here.
Okay.
All right. Well, why can't we just keep the Gene. So Gene already was thinking the 27th, right? All right. Well, if that's still what he wants, why can't? So Albert.
You good, Eugene?
Yeah. Go ahead.
Wonderful. All right. So picking up, in the first evaluation, I'm just going to point to a few examples. Found, 110,000 places in this large code base where APIs were being violated, but dependencies were okay. Found 42,000 places where where for generated files where the same was the case. Found 9,800 places where the APIs were used properly, but the dependency rules were being violated. Now, within that first month, or after this first assessment, a woman named Jill was sent off for a month to fix as many issues as she could. And she cleaned up 30,000 of these architecture violations to drive it to be modular. Unfortunately, when I came back a month later and did an evaluation, we found 430,000 problems, which means that the entire rest of the development organization had introduced 40,000 problems at the same time that Jill had removed 30,000. So this illustrates the need to put lockdowns in place across an organization so that you can collectively drive a process for cleaning the system up. Now, here's an organization we work with, combining the discovery work that we've done where, first of all, you do the evaluation of a portfolio to see the health across it, to build up an ROI-based business case for improving a system, right? So by showing leadership and management that there were challenges, but that it was both technically feasible and economically rational to fix them, and came up with some courses of action, introduced some refactoring. Step 4 here shows why the monitoring is important, because if you don't monitor, then you can drive things in the right direction, but you've got to catch issues immediately so that you can drive them back down and then get this system into a healthy state. Now, this approach, I published an article on this in IEEE around how modular architectures make you agile in the long run. There are a lot of people who are focused on agile software development. Now, and they're very interested in that as a development methodology for helping people evolve your project in a healthy way under high degrees of uncertainty like you often have in the software world. It's been a great thing, but at the end of the day, if you're going to be agile, you need to have both a agile process and an agile product. And an agile product is a modular product because it allows you to dynamically, rip pieces out, change them, change APIs, and adapt and evolve a system without disrupting the entire system as a whole or having to throw the whole system out and start over. So finally, good news. A video game company that we worked with, they went through 3 rounds or 3 attempts at refactoring. And what you see here is that once they finally got their architecture in order, the refactoring was complete, their system was modular, the rate at which that organization was able to produce revenue generating products went up dramatically. So this is not just about cost containment. This is not just about defect reduction. This is also about top line growth and innovation. If you have a modern modular code base, you're able to innovate faster because you are able to play offense more and defense less, and you're allowed to evolve your system in whatever way makes sense. Given that the future of your system might be very different than where it is today, and there's no way to anticipate what the future might look like. So I guess I will pause there, and open it up for questions and a conversation. But that's my underlying message here. We're trying to help people simplify complexity so that they can unleash the potential that their organization has to create and build healthy software at large scale. So with that, I'm going to stop screen sharing and see if anyone has any questions.
Something in the chat. Give me a second here. I'm working off of my hotspot on my phone, so I'm running a little slow. Please be patient with me.
Yeah.
So just a thank you.
Yeah.
So one of the questions I have, not being an IT guy, not being a software guy, the maps that you were showing. So when you identify, like you did with this game, the code that was put into the game 1 to make something simpler that created all the problems later, how is it that you identify that? I mean, do you generate maps yourself? Does your code generate those maps? Are those maps done ahead of time as part of the development process?
No, our tool helps people do that.
Okay.
So we have the ability to analyze the technical health of the system, do predictive analytics around the business impact, and help people see and improve the architectural relationships in the code. And depending on time for this presentation, I could play a quick video that might explain.
Well, let's get to some of the questions. We got questions popping up in the chat. So go ahead, Howard. You had a question? Howard
I'm
Meyer?
sorry, I had to mute myself. I came in late, so I see from a question after me that you did mention DoD work. Who are you working with? Where? What kind of work? And also, if you're doing any work with the Air Force, are you familiar with Big Iron? Over.
Not familiar with Big Iron. I've done a lot of work with the Air Force, Hanscom Air Force Base, FLCMC, PEO Digital, also PEO BES. I've been to Warner Robins, Hill Air Force Base. We've worked with Stratcom. Right now, I think our biggest customer is NORAD, and so I guess technically that's Space Force now. And we're in Joint Strike Fighter. In the commercial realm, you can imagine in the DoD world, part of what we're doing is helping people evaluate the health of software applications that are in existence. And on the commercial side, we help people that are doing mergers and acquisitions. So if software company A is going to be purchasing software company B, they want to know the health of the software assets if that's a major part of what they're buying. And we've worked all across the Air Force looking at hundreds of those kinds of systems: space-based radar, missile warning, logistics, aircraft control code, you name it. Any other questions about that?
Yeah, there's more. So
details.
Are you good, Howard?
Yes.
Okay, so Felicity, you want to go next? I see you had two questions in there, so you can go ahead and do those.
Hi, yeah, sure. I think, yeah, so I'm curious if you're allowed to, or you're happy to say what your kind of overall footprint in the federal government is from a dollar perspective. The second question was, do you contract directly with these government customers, the ones that you just mentioned, or others? And the third is, are you VC funded?
We have raised angel funds, and right now we're profitable. So we're not, happy to. I think we're going to be hitting a growth curve with some of the stuff we're doing. So we are interested in looking at VC funding or other funding sources to meet the demand that we're seeing right now. With regard to, I think you also asked if people contract with us directly. Yes, we've had the government contract with us directly. We used to have a BPA contract. We have other vehicles that we can use, and the Pentagon is about to write a contract for us right now on a major system. We've also subcontracted through companies like Leidos, so we've developed partnerships. We've also worked with KBR. So happy to work with partners, because often we provide the technology to help people modernize and consulting specifically around that. But there might be a service partner that either owns the code base or owns the contract to develop it as the prime, or wants to leverage our capabilities within a broader modernization or sustainment effort.
Thank you. That's fabulous. It's really exciting stuff.
Thank you.
Just a quick question for me there, Dan. Have you looked at a GSA schedule? Is this something you could do on a GSA schedule, or no?
We don't have that on a GSA. We don't have this on a GSA schedule right now. We should revisit that. I think we looked into that many years ago, but it probably makes sense to get back into that conversation.
Right, and they've changed it, because now it's only one GSA schedule. It's not like it was before where there were multiple.
Yeah, it's always a Byzantine process. So trying to figure that out as a startup is a little challenging. But we certainly have lots of different options that we can talk about if you're trying to get.
All right, Mark P., you had a question?
Yeah, so I did. Question is, do you guys run an agile process itself? There's Scrum, XP, Safe, Less, a bunch of different agile processes that are out there, or do you augment, some support to ongoing agile processes as they work them? Because I'm really interested if there's individual contractors that could come in and look at a process that's underway and adjust it, or is it required that you guys follow a certain process that you've developed?
No, so you think about a large organization, the process they might be thinking in terms of Scrum, right? Scrum masters, or Safe, right? So some kind of development methodology for people to write down and prioritize what are the new capabilities that are going to be added in some time increment, and how do we assign people and estimates to those? How do we bubble that up so that everyone's work contributes to the larger goals of the organization? And then how do we track that? Right, that's project management, and there are a lot of ways to go about this. Some people, what we're measuring is the health of the code base itself, and the performance of your organization is driven by both. Although I'd say if you're in a large legacy system, often the constraint really is the health of the code that people are working in, because if they can't understand it and they can't anticipate the side effects, then you can make all the plans in the world. You're not going to meet them if people don't understand the code and things keep exploding on them. Now, people have used our tooling within the context of some of this agile planning. They've said to themselves, okay, in the next time increment, we are going to dedicate some resources to fixing bugs. We're going to dedicate some resources to implementing new features. And then we're going to have a prioritized list of technical health things to improve that we track and manage as part of that process. So what we can offer is the ability to have a structured process around cleaning the technical health or driving modularity into the system that runs as a background activity recognizing that the first priority is always going to be the mission or the the business case. You're developing features for a customer that are valuable. And so this technical health cleanup is an incredibly valuable thing to do, but it is always going to be and always should be a second priority. And we want to make that smoothly fit into whatever planning process you might want to use. I'm not sure if that directly answered the question that you have, though. So was that helpful, or could you comment on if you had another thought in mind? Because I'm happy to, I've thought a lot about.
Yeah, it's, when I think about, you talked a little bit about Scrum, and you talked about Scrum Masters and, coaches within SAFE.
Mhm.
So I was just wondering, like, so the Army is really trying to focus on agile software development and move most of its large projects over into the agile process. But the problem is the aspects of the coach and the Scrum Masters and the education piece. So though some of us have the education, some of us do not. So it's a little bit harder to stretch it into a very large project. I'm not sure if you're familiar with some of the Army projects like Common Operating Environment.
I've heard of it, but I'm not intimately familiar. Be happy to speak offline about the project you got, or even here. I guess one of the things I would say that as a challenge that I've seen is that I was on the Agile Alliance's technical debt working group. So for several years, we worked together on the issue of technical debt and the Agile Alliance's approach to that. And the Agile Alliance is an umbrella organization under which, Scrum and, SAFE and all the others kind of operate. And one of the challenges in that community that's been increasingly kind of a problem in my mind is the vast majority of Scrum Masters or SAFE practitioners, the people who are occupying those roles often have a project management background, but no software development experience at all, right? So in many ways, the project management is divorced from a conversation about architecture, just because the people in those roles aren't wearing both of those hats. And so I'd say that in addition to thinking about having training and education around those kind of project methodologies, you also want to think about technical health as a parallel integrated activity, because you can use, there are a lot of agile practices that you can use that if you use those in isolation will actually make your technical health worse. A lot of the practices, just if you use them blindly, do nothing to improve your architecture. In fact, they encourage its degradation if you're not careful.
Yeah, I think this would be good to move this.
Thank you.
To follow-on conversation.
Oh, absolutely, yeah. If
and
you want
discuss application.
Yeah, specific programs or projects, or I'd be thrilled to drill in more on the projects that we're working on and the projects that you see.
Okay, if you can put your email in the chat when we're done here. Now, one thing that I did not get from you, Dan, that I always want to get from my presenters is, where do you see this going, and what sort of assistance would you be looking for to get it there?
You mean where do I see SilverThread's activities, or
exactly where do you see SilverThread's activities going? Where do you see CodeMRI going? And are there ways that the community could assist you in getting there? I mean, access to research, access to funding. You mentioned venture capital because you're expanding.
Yeah.
So just share a little bit of that with us before you go.
Yeah. So what I'm hoping to do, we've got these two offerings. One we call CodeMRI Modern or Discovery, which is a tool that can be set up to, in an automated way, analyze the health of hundreds of code bases for someone very, very rapidly. And that's a way to see the technical health for strategic decision-making purposes. And so certainly looking to identify people with portfolios of applications where they'd be interested in having that kind of visibility and potential to impose some control. And then the other thing that we're spending a lot of time on is our new approach to using dynamic analysis and these roadmaps to drive technical health into systems. So if anyone has access to or knowledge of larger portfolios of software applications that we might be able to help them look at, I'd love to have a conversation about that because from an economics perspective, if you could just make the decisions about where to place your chips in terms of the resources you allocate to improving technical health across that portfolio, I'd say that you could double the rate of development within a large organization just by making that decision alone. And then if it was about modernizing the system, I think we could double, triple the overall productivity of software development enterprises. It's just a matter of having the same level of visibility and control that we have in most of the other domains out there that we just lack in software. So if you have any thoughts on where large portfolios exist that might benefit from this, or applications that would benefit from modernization, I would love to hear about it.
All right. Thank you. Thank you. I appreciate that. Are there any questions before we move on to ABOTs? All right. So thanks again, Dan. I appreciate it. Sorry it took us a year and a half to get you here.
Yeah,
I guess it's just been a little over a year, but I'm sure you've done a lot, obviously, since we talked last.
Yeah.
And I'm glad you're here and you were able to present. And I think we made some good connections and a lot of good things will come out of this. I want to remind you and the community that, please copy myself on email correspondence. A big part of the focus of the innovation ecosystem and technology ideation is that we don't want to just make these relationships or do these introductions. We want to help make innovation happen. We want to help these solutions go from the ideas that we create here to an implemented solution. When I was with the federal government, a lot of times, the contractors don't want to hang on the federal government because they don't want to upset people, and people within the federal government can get sidetracked with budgetary issues and other things, and things kind of tend to dissolve, and I want to avoid that. So please keep us in the loop. Again, thank you all. Thank you for the great comments.